All right, awesome. And we are live. Let's give people a minute or two to show up. This is the first episode of the Cool Data Project Show. Just give me a second to take a look. Oh. Yep. I see us there being live on LinkedIn. Okay, awesome. So we are here today with James, who is going to tell us about his super interesting project that he's been working on. Her name is Veronica. She leverages both NLP and computer vision for her project, for his project, but Veronica's a girl. And so before we dive in, James, would you like to introduce yourself?
Absolutely. So I'm from India, and currently I work as an architect at SparkCognition, and in my free time I pretty much go around and do evangelism around artificial intelligence, and I'm pretty much an ambassador for NVIDIA's Jetson as well. And when I'm not coding, I pretty much beatbox. I think that's something very few people know. And yeah, that's just a little bit about me.
Oh man, that's so awesome. You'll have to beatbox for us at the end.
Sure.
I have literally been waiting since I think the first video I saw of yours was in 2019, maybe on LinkedIn. And I just remember seeing the really cool music, the cool outfits, and the very cool things that you were doing, obviously. So when I decided to create the Cool Data Project Show, you were, of course, the first person that I thought of. For anyone who doesn't know who I am, my name is Kristen Kehrer. I am a developer advocate for Comet. Comet helps you easily make your machine learning reproducible and also gives you the tools to easily compare your models, both, the code between different runs and through graphics, as well as monitoring your models in production and some more. So that is me. I'd love to get right into a demo so that everyone who's on can see exactly what we're talking about with all the coolness. All right, so this is the demo.
Initialization complete.
Veronica, start visual interface.
Starting now.
Veronica, mark a car in blue.
Marked car in blue.
Veronica, mark person in pink.
Marked person in pink.
Veronica, mark person in green.
Marked person in green.
Thanks, Veronica. Veronica, begin flight interface.
Beginning drone flight.
Veronica, sentry mode.
Looking out. Remotes.
Veronica, do a flip.
I'm so cool.
Oh man, that was so cool. So cool. Let me just get myself situated here. Okay, so we have had a couple of comments as well. Puneet says, this is amazing. Can't believe I have a meeting right now. And he asked, will there be a recording of this available? Yes, absolutely. There will be a recording available. I'll both be sharing this live. And It'll be going up on the Comet ML YouTube channel. So Kate said, hey, Kristen, so good to see you live. It is so good to see you here, Kate. Thank you for coming. Same with Ravi. Thank you so much for showing up. Thank you too. Happy that everyone's here and watching. Okay, so let's dive into this. So what first gave you the idea for this project?
Just like a little bit of backstory, right? So I guess computer vision was the most interesting aspect for me in the vast field of artificial intelligence, right? But the more I kind of dived into it, the more I realized that what exactly constitutes human intelligence, right? It is a combination of all of our senses and actions that we take. So and NLP was also really fascinating to me. At the beginning, when I started off my career, it was difficult to work with NLP, but later on, I kind of got a hang of it. And I have this huge inspiration from fiction, right? Science fiction, and there are so many examples of virtual assistants, right? And I guess the most popular one out of them is Jarvis. And the way Jarvis works is not just NLP, but there are like a million examples in these movies and comics, right, where Jarvis is actually taking decisions or responding because he has visual information as well. So the idea was to kind of recreate it as much as I can. Initially, it seemed like far-fetched, like I'm never going to reach that kind of accuracy levels, right? But as I kind of started working on it, and then I had these light bulbs go off my head, and I just started getting some ideas, and I put it together, and I just called her Veronica, right? And the inspiration for the name Veronica pretty much came from Iron Man as well. So it's actually this satellite in movies that holds the Hulkbuster armor, right? When Iron Man faces Hulk. So I really like the name, and I was like, okay. And a little less known secret is when my NLP skills were not polished, other names that I was trying to code down weren't working. And Veronica, since the syllables were really good, I got a good, the ASR that I was using was able to identify that I was saying Veronica. So, it was convenient.
So Veronica it is. Awesome. And so you were saying, that the light bulbs were going off. So, hands-on sort of, what does that look like when you've decided you're going to take on this project and you're thinking about like, okay, how am I actually going to, what am I going to do first? Walk me through sort of what you thought about in terms of how this project would, a little bit of methodology, that sort of progression.
Okay, so in terms of my the way I construct ideas, right? It does have to do a lot with the kind of architectural skills that I've picked up through my career choices, right? And the gist of it is that I break down every bigger problem into smaller problems, right, and try to layer them in terms of complexity. So, when I started off with Veronica, it was like, you know what? Let me just get the automatic speech recognition part working. So let me just say something, and let me see if it can convert my speech to text, right? And it was doing that. So I was like, okay, now I need a mechanism to trigger Veronica, right? I need a hot word. And at the time, I didn't call her Veronica, right? So, it was just an application that I was working with. So I was like, let me just try to see if I can code down a hot word, right? So again, just as I said, I experimented with a couple of names and landed up with Veronica. So once I had that working, that's like the basics, right? So now I know how to trigger my application with my voice, and I can give it an input, right? So that makes the base skeletal system of my application ready, where I can code down something, compile the application, run it, see if it works. If it doesn't, then again go through that loop, right? And the very first thing that I did with Veronica was actually not that exciting, right? So it is something that Google Assistant or Siri could do. It was as simple as, hey, can you tell me the time, or what's the weather like today? And I know there are like a million examples out there, but what I actually believe is when you are starting off with something, you need to take a lot of reference points, and you should try to achieve something that someone else has already built, right? So if it's as simple as object detection or image classification, if you're new to it, I the way I preach is, why don't you try to do something that someone else has done already, so that you get accustomed to the tools you're using. Once you're accustomed to it, you move on to something that someone else has not done, which is unique, right? So same thing, the initial things I did with Veronica were pretty generic, and then I was like, okay, now that I have a hang of it, now that I know how I can create an intent classification and get understand the input that I'm giving and take actions on it, I started, at least I tried to be creative, right? So I tried bringing in drones. I tried, having a mapping between a computer vision application running alongside Veronica and so on, right? So I knit everything together with a lot of tools and technologies that are used in the Internet of Things. So with the video that you just played, the way Veronica was communicating with the object detection pipeline was over MQTT. So the object detection pipeline would keep running. It would give a feedback to Veronica, and Veronica would give instructions. So essentially, that's how I went on and built it, and just essentially build it like modules, right? So that you can play with it like a puzzle. Remove the pieces you don't want and plug in the pieces that you want.
Can I ask too, how hard was it to find a drone? I just know nothing about drones. How easy was it to find a drone with like a friendly API that you knew you'd be able to? How hard?
A good question. So the drone I used is a Rise Tello, and I think it was one of my friends. At that time, the dude was not my friend. He was just a junior of mine, and I was a judge in a hackathon. And so it was late in the night, and I was just doing my first round of evaluations of how well the teams are doing, and that's where I saw him, kind of use this drone, and it had a really friendly API. It communicates with your laptop or any device that you're using over UDP, and it's really easy to control it, right? So it gives you low-level control. The amount of rotation you want, the elevation, if you want to increase it or reduce it, and so on, right? So that's the kind of drone I used. I've also used DJI drones. They're not that easy to use because of the interface, but they do give you a lot of control. So, I mean, if you're getting started, a developer-friendly drone makes sense, like a Rise Tello or a Parrot AR. And if you want to build robust applications that might be used in the field or in real life, then maybe a custom drone or something that's built by DJI makes more sense.
Okay, fascinating. And we did have a question too from the audience. What did you use for ASR?
Oh, good question. So the stack I've been using is from NVIDIA, and it's called NEMO. So they are neural modules essentially, and they do provide pre-trained neural networks for automatic speech recognition and TTS, right? And also converting your spectrograms to actual voice. So I believe I was using QuartzNet for this demo, because I could have used something which is heavier and more accurate, but my aim has always been to make it real time and run it on a single machine, right? So, I mean, I don't always have the luxury of multiple GPUs. So it only makes sense for me to try and make the application as small as possible so that I can experiment with it on the go. So in short, the answer is QuartzNet.
I like that. Experiment on the go. Feels like a tagline. And Scott has joined us too. Hello, Scott. So nice to see you. So what algorithms can you tell us about the algorithms that you're actually using for your computer vision and NLP?
Sure, absolutely. So on the NLP stack, I'm using QuartzNet, as I just mentioned. I'm using a lightweight version of BERT. Um, for TTS, it was Tacotron 2. Yes, it was Tacotron 2. But now I'm in the phase of shifting it out. Tacotron 2 is quite old. When it comes to computer vision, based on my demos and the algorithms that are currently in Veronica, there is YOLO V5, which is for object detection. I'm just using the pre-trained version of it. So, um, I could just directly download the weights and plug it in. For face recognition, it was a ResNet-based classifier trained with additive margin loss. Yeah, that's what it's called, or arc loss, right? So that is what I was using for face recognition. And when it comes to any classifiers you see on my screen, they're pretty much random. I just pick the one that has the best accuracy and performance ratio. So it's usually ResNet or EfficientNet.
Awesome. And can I ask a question too? This one's more. So you said you were using YOLO V5. I'm using YOLO V3 on my model simply because it was very easy to use with Image AI. I don't actually know much about computer vision, but somebody had told me that the YOLOs have a high false positive rate often. Do you know anything about that? Do you have opinions on that, or?
That's actually a really good point. YOLO V3, V4, or V5 are kind of susceptible to overfitting on your data, and you tend to get a lot of false positives as well. So there is a way to circumvent this. Rather than doing the usual training, right, which is just creating a data set, randomly splitting into training and validation splits, and then training your model. There are a couple of tips and tricks that you need to keep in your mind, right? One, and I keep telling this to everyone, so do not randomly split your data set. It makes no sense, because one, you cannot compare your results to someone else because random, right? Two, when you actually do a random split based on how your data is shuffled, you are not going to get the exact samples in your validation set that need to be that are there in the training set, right? So let's just take a small example, and let's consider a cat, right? So a cat could be in any orientation, and a cat could be fully visible in the image or partially visible in the image, right? And if you've done a random split, you can mess with the number of samples that you have. What if your random split actually took all the easy examples where the cat is fully visible in the picture, right? And it actually skips samples where only a part of the cat is visible. Maybe the legs at the back and the tail, or maybe it's just focused more on the side of the cat, and so on, right? So that's where you get these variable results. And creating a train and validation set has to be methodical and not random. The other thing,
Stratification, like taking a couple partial images, like maybe taking all your partial images, randomly sampling those, but also randomly sampling from the simpler ones, like a stratification sort of.
No. So what I'm, I mean, not exactly in the same way that you mentioned, but rather you can just think of the entity or the object that you're trying to train can exist in various orientations and permutations and combinations in the universe, right? And when I say universe, it's more of a set, the universal data set, right? If you don't make a good split between your data, then your results are not valid, right? And a lot of people actually collect data, and they randomly split validation out of it. You possibly also are taking out samples which were needed in the training set, right? So hypothetically speaking, let's just say you have 1,000 images, maybe 500 of them are of the entire body of the cat being visible. 200 of them are only the face of the cat, and maybe another 300 are for the tail and maybe partially occluded images, right? And if you do a random split, you might just take away, let's say, the face of the cat, right? Most of the images might be that. Now your training is going to overfit, only on a couple of images, and your validation is going to look bad because your training data set now doesn't have images of the faces of the cat, right? So you're going to get fooled into thinking that your model just got overfit and your validation sucks. So probably the neural network is bad, and a lot of people just randomly just replace the neural network, right? So when you're training models, it has to be data centric. A lot of effort needs to go into how you clean and prepare your data, and most neural networks actually work out there, right? So that's like the major thing that you need to keep in mind. And this was a classification example. It holds good even for object detection, right? So you might have samples where you have partially occluded objects, and you will have samples of fully appearing objects, right? So you need to be careful how you split the data. And about YOLO's overfitting problem, uh, uh, a lot of it can be handled by the augmentation you do, right? So again, a lot of people, they just use the standard augmentation techniques, or they just use the standard or default values that are provided in the repositories, right? And but if you experiment with it based on your data set, you can get better results. I can probably try to give an example, right? So if you want, let's just say you want to detect people, right? And people can occur in a lot of permutations and combinations in terms of orientation and the clothes they wear, and their skin tone and their hair and beard and accessories and so on, right? So you want your model to kind of generalize on those aspects, but learn on what actually makes a human human, right? So the humanoid figure, as in you have two legs, two hands, two eyes, and so on in most cases. So you want a model focusing more on that. So you would go with augmentation techniques which variate color a lot. They might do a lot of rotation on the images, because humans can occur in a lot of orientations, right? So the way you augment data, you need to guide your neural network into generalization, right? So if you use just default values out there, it won't really make sense. Um, another maybe another simple example, right? I want to make a detector maybe for my AirPods case, right? So this is like slightly pink in color. I know this is not going to come up in another color orientation. This is exactly what I want to detect. This is not going to be yellow, this is not going to be red, and so on, right? So I would stay away from color based augmentation techniques. In this case, I would turn them all off, because I know that my AirPods case is going to look exactly like this, right? And I would go really heavy on augmentation techniques where I would rotate the image, I would flip the image, I would shear the image, destroy the quality of the image, and so on, right? So that way now I'm guiding my neural network into understanding that this is what my AirPods case looks like. Don't go and identify if you see another oval shaped object of a different color or so on, right? So essentially, these are the myths and bits you need to focus on to get the exact accuracy. And this I'm telling from experience, because we use YOLO models in production, right? We are using YOLO v3, YOLO v4, and YOLO v5 on case-to-case basis, and this is the kind of methods that we kind of follow, and make sure we don't really go into the bad loop of false positives or missing out detections or overfitting.
That was a really good tip, actually, because I need to, a lot of my training data is the bus passing my house, and I could do a lot more to rotate and distort those or whatever and increase my data set.
Right, right.
So
And since you're only detecting a bus, I'm assuming a school bus based on our previous conversation, and school buses are yellow, as far as I know, where you live. So, you would, like, I would suggest not use any kind of color augmentation in this
right.
case, right? Because that it doesn't make sense. You're not going to have a red bus any day. So, and you really want it to only detect a school bus, which is of a specific type. So,
Yeah, no, because I was trying to get more data. So then I'm going to the internet, and now I'm like, wait a second, I'm only trying to do this one thing. I don't need to introduce anything extra. But
right.
what you said too about the random split, I don't know if this is like, the corollary, but in tabular data, right, it's just so simple to say, okay, I'm going to randomly take test and training. And if the samples are large enough, I can very easily, with a couple lines of code, look at the distribution of every single variable for all 50 variables. And if the distribution doesn't match, that's an easy fix. I can just resample that. But all of a sudden, when you're working with image data, it becomes a much larger lift to try and understand that like one small piece.
Because when you're working with tabular data and machine learning, you have a lot of columns, right? And the columns kind of tell you or give you that distribution that you're doing in your EDA. So when it comes to image data, right? When you're classifying data, essentially nobody or you don't really have data sets that are annotated to a level where a lot of information about the data is present, right? So as I said, a cat could be in any orientation. So we could have one additional parameter like fully occluded, partially occluded, no occlusion, right? So if you had that data, then you could do training and validation, and kind of get a distribution. So you can tell that I have 100 samples of occluded, I have 50 samples of partially occluded, and so on. So very few data sets are annotated to that level, like the COCO data set. But in general, so what we do, when we're working with data sets or when I personally work on projects, so when I'm gathering data, that's where I start splitting, right? So again, these are supervised learning techniques, right? A lot of human intelligence is necessary. So essentially what I'm doing here is when I'm gathering data, when I'm if it's videos, if I'm breaking down the video into individual frames, if it's just collecting images from the internet, I'm sorting them out and so on. And then when I'm creating my train and validation set, I am splitting it the right way, right? So if I have like 50 samples, collected from a specific video, then what I would do is like probably have like 40 of them in training and 10 of them in the validation set. So that way, my validation set appropriately represents my training set. So that's the kind of practice I do with image data, essentially.
Yeah, no, this is an awesome awesome conversation, and you've hit on a lot of different points. So you've already mentioned sort of some of the things that you were considering when you were choosing these algorithms and creating your data set. Were there any other challenges along the way that you think other people could really benefit or avoid themselves?
Oh, right. I mean, challenges come all the time, right? I mean, it's I guess bugs and things not working and your code not compiling are curses that us developers have, right? I mean, we just can't get rid of these small nuances. So essentially, some of the challenges I would say with Veronica at least was being real time, right? When I'm saying something to Veronica and if I'm getting a response which is like delayed by like 2 or 2.5 seconds, it's not that great to see, right? I wouldn't like it. Anyone watching on the internet wouldn't like it either, right? So I guess speed was one of the biggest challenges, and speed directly correlates to optimization, right? So training a neural network which is accurate is one part of the challenge. The second is when you make it production ready, right? So that's where you go towards optimization and you start noticing at performance and accuracy ratios and so on. So I think the biggest challenge for me was to get multiple models running on a single GPU. And what I noticed is, when I'm using basic frameworks like PyTorch or TensorFlow to run my neural networks, or basically do inference with my neural networks, they don't really share a state, right? They divide the GPU amongst themselves, and everything runs slowly. So if you deploy one model on a GPU, sure, you get some amount of speed. You go ahead with another model, then both these models start, sharing the GPU, and the speed kind of slows down. So in my case, since I had prior experience with NVIDIA, and NVIDIA does have a lot of libraries that help you speed up your, inference game. So I think one of the major challenges was using TensorRT, right? So using TensorRT, convert your models to TensorRT format, and then get accelerated inference, right? So maybe just as a small gist, what TensorRT does is they have optimizations that merge different neural network layers, and they provide a shared GPU access, and they have different quantization levels as well, like FP32 and FP16 and so on. So that kind of helps you speed up more and more. And once I was able to get all of my models loaded on the GPU and run inference accordingly, that's where it was easy for me to build Veronica as well, right? I think that also increased my development time, because I would develop something and then run the application. There's a good chance that it doesn't work or misbehaves back with me, like Veronica misbehaving back with me. But you know, uh, uh, essentially that also helped me speed up my development time, right? So that was like one of my primary focuses, like get the base architecture working as fast as possible, and then I could work on the use cases, right? So the next thing, I guess, was having low latency communication between the different modules that I have. So on face value, you see it as Veronica, but for me, there are different modules running which are like communicating with each other, essentially, right? So there is a face recognition module. There's another module for object detection. I'm using Deepstream to run my object detectors, so that's one entire service that's running on its own. I have Veronica's set of models running, the intent classifications running at another place. So essentially, I knitted all of these things together with MQTT, right? So MQTT is this protocol that you can use for quick data transfer. It's a publisher subscriber model. So I laid out this architecture, and every time a module generated data or wanted data, it would get that data from another module, or it would request data from another module, right? So when I said Veronica, like for example, if I say Veronica kind of lights up, starts accessing information from my microphone. She hears me out for a while. The automatic speech recognition kicks in. It converts whatever I say into raw data, so just a raw string, and that has a lot of mistakes. So that goes through a lot of filtering and correction, like punctuation and capitalization, and a couple of models for spell checks and so on, and that creates an actual sentence. Once that sentence is ready, then it goes to the intent classification. I need to figure out my intent classifier needs to figure out what exactly I'm telling Veronica to do. Um, Once it knows what I'm trying to do, so for example, if I'm telling Veronica, hey, can you take off the drone, right? So now that has to go to the drone module, which is another application which is just waiting for instructions for the drone to do something. That gets the message over MQTT, and then it responds back saying that, hey, your action is done. And that response comes all the way back to the TTS of Veronica, and then Veronica just picks a very quirky reply back based on whatever I asked her to do, right? So that's how I kind of layered it all out.
So, I mean, and I'm sure this is more of like a iterative thing and you thought about it as you were going along, but when you've got a couple modules working together and the latency isn't where you want it, like what's the first thing that goes off in your head as to what you should look at?
Okay, so first I would pick a model actually by seeing the size of the model, right? Or at least I guess that's a skill that I've developed over time. But if let's just assuming that I don't consider those things, then I get a model, I see what its latency is. I try to check how much of my GPU it's using, both in terms of memory and the CUDA cores that's there on the GPUs. The next thing I would see is if I can optimize the batch size or the input size. So if it's a neural network for images, I could optimize or I could reduce the image size that I give to the detection, or to the object detector or to the classifier, right? That's one thing I would do. I'd see how much of an improvement I get. kind of note it down because these are iterative steps that you take, right? And you also have to make sure that accuracy doesn't fall down when you're doing this. Because if I'm running inference on a smaller image, then my results are going to be less accurate. Oops. Give me a second.
You all right?
Yeah, my iPhone's not being a really good iPhone today. Okay, all right. So going back to where I was, just make sure the accuracy doesn't drop while I'm making these changes and trying to reduce the amount of time the neural network takes. The next thing is you go into a slightly more complex techniques of making your neural network smaller, right? So one thing is quantization. So you could run all of your operations in FP16 instead of FP32. So that's half the amount of operation speed, right? At least the hypothetical result of that. That's one thing that I usually do. I try to see if I can, get rid of a couple of connections in the neural network. So that's called model pruning. So the lesser connections you have, the faster your neural network gets. And pretty much, I guess the last step for me is to go towards TensorRT, right? So if I really need that speed, and if I'm not able to optimize it as much, I just go ahead and use TensorRT and then go about it. If none of this works, then you have to get your hands dirty. You'll have to get a neural network. You'll have to train something by yourself. You'll have to make major modifications to the neural network, figure out the layers you want, you don't want, and retrain it yourself and use that. So at least with Veronica, I haven't done that really. It's Veronica is more of a platform for me to experiment with things, right? So I don't really want to make it production grade yet. That's not my intention. It's more of a playground for me to work on. And every time I find something new, I just go ahead and plug it in. But I still try to keep optimization in my mind.
All right, awesome. Yeah, no, that's a lot of good stuff. And then even when you're, because this is a personal project, when you're working on your own stuff, like, are you really good about best practices and what does that look like?
So in terms of best practices, I guess writing down your problem solves 50% of your problem, right? So if I can note down the things that I exactly want to do, it helps me keep myself in track, right? So that is essentially one thing I do, and breaking down my problem into modules, essentially, right? So you want your application to do something, so it's going to have those several different modules stacked over each other, right? I guess a good analogy I can give is functions when you're writing any kind of a program, right? You divide groups of programming statements or lines of code that are going to be called over and over, and you create a function out of it. A group of functions that essentially need to be used with each other, or if they have certain attributes that are similar to each other, you put them in a class, right? So that essentially is how I layer any problem as well. You break it down, get one module to work, move ahead, get the other module to work, and so on. If I were to take a different kind of approach where I just get everything on board and then dump it down and then try running, you will not understand where the bug is at, right? Because it could be one of your modules not converting the data properly. Maybe you have done the wrong format. If you have like math involved, maybe you've written multiplication instead of division. I don't know. You could just mess up a lot of things, right? So there's essentially a lot of things that could happen, and so the kind of practice I have is break it down, get one module, get it working, move on. And logging, I think this is like really important, right? So you should have some dev level logs, and if it's someone who's starting off, it's completely okay to not use a logging framework or some fancy library that helps you log. A simple print statement can do, right? So if you can just say that, like you can just print out the data you're getting and the function and the name of the function, right? So that way, when you have like various functions being called one after the other based on your logic blocks and so on, at least you know how the data is flowing through your application. So in case if you have a bug in your if else conditions, right? Maybe you want to write if x is greater than 100, but you ended up writing less than 100 in some situation, right? So before the if condition, it just makes sense to write the name of the function and write out the value of x, right? So that way you can see, oh yeah, I can see that it's 67, but it's not going inside my if condition. So I need to check my if condition. And then you'll scroll through your source code, go to that specific if condition, and then you'll find out, hey, I was supposed to put a less than sign, but I put a greater than sign, or whatever the, I mean, you could have any kind of bug, right? So that just makes it easier for you to stack trace and build your application.
Okay, awesome. No, those are some great tips. And I'm biased, but of course, I think that the Comet ML library is a great best practice as well to make sure that your work is reproducible. And you can use that by just, if there's a community edition, so the Comet_ML library allows you to easily reproduce your results. And so what do you think is the final state of this project that you're working on? Is there a place that you're looking to get to, or do you think you're just indefinitely going to be playing and tinkering with it?
I do not believe there's an end to it, or I would stop working on Veronica, right? Because I mean, technology is constantly going to keep developing, right? So I will always have that opportunity to plug out something that's old and plug in something new, right? So, if a new kind of object detector comes in, maybe an object detector that's based on a transformer that's really good and really fast, I'm just going to plug out something that is CNN based, right? And plug a transformer in. And there are a couple of wild thoughts in my head with Veronica. So I believe that you can create general level AI, or in other words, AI that is somewhat comparable to human intelligence, right? Only when you combine different aspects of AI together, and that's like one of the motivations to put NLP and CV together at this point, right? Before it just started off as something cool, but now it's more of an exploration for me, right? So in the short term, the kind of things that I'm looking at is Veronica having the ability to constantly monitor what I'm doing, right, and make decisions and actions based on that. So again, it's a simple comparison to what we see in science fiction, right? So you have AI that can see you, that can understand your emotions. They also have information of where you've been, what you've eaten, how much of it you've eaten, and what you're doing currently, if you're reading, you're sleeping, and so on. So if I could just gather those kind of data points of myself, I don't really know what I'll build, at least now. I guess right now I'm in that phase where I should collect this data. And when I start seeing a pattern, then I'll try to give capabilities to Veronica, right? So that is one thing. And second, I did explore GANs a lot. And with GANs, I've seen this capability where with noise, you can essentially create something beautiful, right? So the whole point here is, I essentially want parts of or different applications that are powered by GAN to be, a part of Veronica, right? So I mean, really simple, but and this is something that I could plug in really easily based on how the architecture is right now. So you do have GANs like VQGAN and Clip, right? That if you write a caption, they create an image out of it. So I could write a caption like, a sinking ship in the middle of the ocean with a bright red moon, right? So these kind of GANs essentially understand what the user has written, and they can create images out of it. So maybe have something like this in Veronica, and a simple thing could be maybe Veronica just notices or understands what I do on a daily basis, and based on my mood, it could generate an image for me in the night to see, right? So it's like a virtual logbook, but completely based on AI. I did not write anything. I didn't take the effort of picking up a pen and a book and just scribbling down what my day was like, but rather Veronica just collected different parameters and data points of what I did and generated an image at the end of the day, right? So that's like some of the wild ideas I have, and eventually try to grow Veronica more and more towards having general AI capability and not just being a virtual assistant.
Yeah, no, I love that. With noise, you can create something beautiful. I thought was so poetic. And I agree. Like I remember a lot of what I did in when I was working in time series analysis was we'd use like seemingly unrelated regression to pick up on, the really non-noise that was in the noise that looked like noise, but it wasn't really noise when you got, when you really got into it.
Right.
Okay. So I think that's where we're going to end today. I am so thrilled that you came and joined me because this was an amazing session and you had so many awesome points to share. I know I personally learned a ton myself, and I'm really excited to watch and see how this project continues to go. I hope that you are sharing more YouTube videos soon. If people want to follow your work, where can they go to find you?
Now, I think the best place is LinkedIn. That's pretty much where I just, cook up my stuff and post it out there for the world to see. Probably Twitter is a good place. That's where I can reply to people because my LinkedIn does get flooded a lot with messages. So, I am, I am in the wrong here that I do. I do skip on a lot of messages on LinkedIn. So, probably Twitter for messaging and LinkedIn to follow my content.
Or just make the LinkedIn messages real wild. Someone says something crazy.
I guess that would work, right? Because a lot of people are like really respectful and they're like, "Hi Akash" or "Hi James, I hope you're doing well," and that's something I can't really respond to. And if someone just said something quirky, I'd probably just open it, right? So
keep life spicy, right? Do you have any, final comments that you really want people to, hear or know? Is there something that, you want to share?
I guess keeping the title in mind, right? So if you're starting off with AI, I guess don't be afraid. Go out there, explore what other people have done, try to replicate it, and then create your own thing, right? So it is really easy to code and it's really easy to work in AI. I'm not trying to be biased, but I guess AI today is easier than doing something like database or writing queries. I think the amount of content out there and the amount of blogs, the amount of videos out there that help you get started with AI is a lot, and they've just made it really simple, right? So I guess keep exploring. And if you do have that interest, I would suggest don't kill it if you find it hard, because it's hard today, but it's not going to be hard later on.
All right, awesome. And I do want everyone out there to know, if you're out there thinking, man, I have a really cool machine learning or deep learning project that I'd love to share, you can feel free to reach out to me and, let's chat about it. But yeah, James, thank you so much for joining me today. I really, truly thought that this was wonderful. And I'll probably be watching it myself again because I thoroughly enjoyed it. All right.
Thank you. Thanks for having me on.
All right. Thank you very much, everyone, for hopping on. It was really great. So glad you joined us, and I hope to see you soon. Goodbye.
Goodbye.